Hi, this is Mrs. Seibert, and we're going to be doing metric conversions today. So this is a little preview on what we're going to be doing in class with metric conversions. So the first thing that you'll need when doing metric conversions is your base conversion equations. For example, 1 kilometer equals 1,000 meters. 1 meter equals 100 centimeters. 1 centimeters equals 100 millimeters. So here's an example of the type of problem that you might see when doing metric conversions. 32 kilometers equals blank meters. So the secret to metric conversions is knowing this equation, and then you don't have to do math. We have to do something called decimal magic. So in our example, we have 32 kilometers equals blank meters. So here's what we do to solve these type of problems. First, you need a ratio table. This is going to help you figure out your decimal magic. So we have kilometers, and we want to put this number into meters. So that's what we're going to put in our ratio table, kilometers to meters. That's where this equation comes into play. 1 kilometer equals 1,000 meters. So 1 kilometer, 1, make sure you're paying really close attention to your units. That's what's going to help you. And if you don't, it'll trip you up. So 1 kilometer equals 1,000 meters. So this equation is what's really going to help us figure out how many 32 kilometers equals blank meters. Some of you may be able to see already that you really just multiply 1 times 32, so you need to do 1,000 times 32. But I promise you that as we go on, equations are going to get harder, so we're just always going to use this ratio table to help us. So then the next thing you want to do is put in the information we know. So we know we have 32 kilometers, and we're trying to figure out this right here in our ratio table, this blank meters. So in our ratio table, it's nice because it organizes all of our information. So for example, how do we get from 1 to 1,000? We multiply by 1,000. So ratio tables are all about patterns, meaning 32, we have to do the same thing to get from kilometers to meters. So 32 times 1,000 is what we have to do to get to our meters. This is where our decimal magic comes into play. So we have 32 kilometers. Remember, every whole number is a secret fraction, like we talked about before, with a denominator of 1, but it's also a secret decimal. A decimal in every whole number is at the end of the number. So we could rewrite this 32 as 32 and 0 hundredths. And remember, we can add zeros for the rest of our lives, and it would still be the same number, the same value. So here's where our decimal magic comes into play. If we are multiplying, then the decimal moves to the right because we're making the number bigger. If we're dividing, then the decimal moves to the left because we're making the number smaller. Okay, in this case, we're multiplying, so we know we're going to move this decimal to the right to make the number bigger. Now, we're multiplying by 1,000. That's how we know how many times to move the decimal to the right. In this case, 1,000 has 1, 2, 3 zeros, which means we're going to move the decimal to the right 3 times. 1, 2, 3. That's our new place for our decimal. So we actually have to add zeros in these empty places. So our 32 in meters now looks like a 3, a 2, and 3 zeros. The decimal after. Remember, our place value, ones, tens, hundreds, comma. So we now know that 32 kilometers equals 32,000 meters. Let's see another example. So our new example is 64 centimeters equals blank millimeters. Again, the equation that will be given to you for now is going to be 1 centimeter equals 10 millimeters. 1 centimeter equals 10 millimeters. Remember, this is where our ratio table comes into play. We're going from centimeters to millimeters. Okay, so we know that we have 1 centimeter equals 10 millimeters. We actually have 64 centimeters, and we're trying to figure out how many millimeters. So remember, secret decimal at the end of our 64. So over here we have 64. And if we see, we're going from 1 to 10, which is times 10. Times 10. Multiplying means the decimal is going to move to the right, and 10 has 1 0, so it's going to move to the right 1 time, add that 0. Now our number looks like 640 with a decimal at the end, which we know reads 640 millimeters. So again, just to clarify, metric conversions, you have this magical equation that helps you. You use a ratio table and some decimal magic. So again, this is just a preview. This is something we're going to be working on in class. Thanks for viewing.